Hey guys, here's our notes from Wednesday about multiplying rational expressions. So it goes into our new digital notebook. You can fill in your table of contents. So with multiplying rational expressions, you want to title your paper. You just need a piece of paper, and then you need your workbook, unit 2B. You don't have to write down the essential question. Remember, the essential question is already on the slides presentation, but on the at the end we want to be able to answer, how do you multiply rational expressions? So first we're going to talk about how you multiply fractions. So the way that you multiply fractions, just like in general. So we're going to look at 2/3 times 3/5. The way that you multiply fractions is you go straight across the top. So 2 times 3 is 6, and you go straight across the bottom. 3 times 5 is 15. Then after we get our answer though, we might have to simplify. You notice 16 over 15, those can both be divided by 3. So it'd simplify to be 2/5. Now we're going to talk about how to simplify rational expressions. Rational expressions means you're going to have fractions, but they're going to have variables, exponents, that kind of stuff. Okay? So the first thing that you always do is factor. So how you factor just depends on your problem. You always start with GCF, and then you can try, if there's 3 terms, you can try snowflake, difference of squares, some difference of cubes. But after you factor everything, you cancel if possible. Then multiply whatever's left over, or whatever remains. So we're going to do that same example we just did. We're just going to change it a little bit and do this kind of method. So 2/3 times 3/5. So instead of multiplying straight across the top, straight across the bottom, we would try to factor first. The number 2, 3, and 5 are all prime though. We can't factor them at all. So then we would just cancel if something's the same on the top and the bottom like we did last night. Well, it happens to be that there's a 3 on top and a 3 on the bottom. Even though they're not on the same fraction, after you multiply, they would be. So what we have left over is 2/5. We got the same answer that we had up here, 2/5, but we didn't have to simplify at the end because we canceled out their common factor of 3 at the beginning. So the other thing we need to write down is just a reminder about your invalid values. They might call them extraneous, restricted, but you find invalid, restricted, excluded, extraneous, values by setting the denominator equal to 0. Well, there's going to be 2 denominators. So whatever would make 0 in the denominators, those values are invalid. They're restricted, they're excluded, they're extraneous. All right, we're going to take a picture of this. This is going to go into your slides presentation. Let's go do our examples. This is in workbook, unit 2B. This is page 29. So the first step, it says identify any invalid values. So the way that you do that is you look in the denominators and you think to yourself, like, what would make it equal 0? Okay, this you can do some mental math with. If it says x plus 1, that means that minus 1 would make 0, and you just say x cannot be equal to that. Now we're going to go to step 2, which says rewrite the second term as a fraction. So we have 3 over x plus 1. We make 8 a fraction by just putting it over 1. Here they ask you to multiply the expressions and then check to see if it can be simplified. We always try to simplify first and then multiply. So when I look, I try to see if anything can be factored. Well, 3, that's prime, right? Can't factor that. So we're just going to leave it. X plus 1, that's a polynomial. So first you check for a GCF. Nothing divides it evenly. There's 2 terms, but it can't be a squares or cubed because there's no power of 2. So I'm just going to put parentheses around it to remind myself that they go together. You can't break them apart. That number 8 technically could be factored. It's 2 times 2 times 2. I'm not really going to waste my time of writing it out though because there's no 2's or anything on the bottom. So unfortunately, I can't cancel anything out because there's no 3 on the bottom, there's no 8 on the bottom, or anything that divides into 8, so we just have to multiply straight across the top, straight across the bottom, 3 times 8 is 24. X plus 1 times 1, well, anything times 1 is just itself. And then we just state our excluded value we had earlier, which is -1. Okay, so that's example number 1 on page 29. Let's go to the other side, example 2. So again, I just go through my pieces and I see if I can factor. So I have x minus 3. Well, it's polynomial. There's no GCF. Nothing divides into both. It's not a squares or cube problem, so you don't see any power of 2. So I'm just going to put parentheses around it to remind myself that they go together. Then I have an x on the bottom. Well, x, that's a monomial. Just put x. So I can't simplify it any further. I have to make the 5x a fraction, so I put it over 1. 5x is a monomial, so 5 is prime. There's nothing really I can factor. I could break it apart into 5 times x, though. All right, don't cancel anything yet. Think to yourself, can I cancel these x's? One's on top, one's on the bottom. No, I cannot cancel anything because the -3 and the x are holding hands up here. Can I cancel these x's? Yes, actually cancel those ones on your paper because one's on top, one's on the bottom. These guys are just standing next to each other. They're strangers. They're not holding hands. You can break them apart. So the x goes away on the top and the bottom. On the top now, we multiply x minus 3 times 5, so I have to distribute. I get 5x minus 15. On the bottom is just 1. I don't have to write that, so it's just my answer. I do have one extraneous solution, one thing that x cannot be equal to, and since this right here is an x, what would make that 0? Well, just 0. So we say x can't be 0. Example 3, we're going to do the same sort of thing. We're just going to factor if we can, and then cancel if we can, and multiply whatever's left over. So on top I have a 5. That's just prime. I can't, do anything there. On the bottom I have x. That's also prime. I can't do anything there. Then I have x plus 1. Well, there's no GCF. Nothing divides in evenly to both. There's no square or cube since it's only 2 terms. But I am going to put parentheses around it to remind myself that they go together. On the bottom I have x squared, which is a monomial, so it's really just x times x. And don't cancel anything yet. You think to yourself, can I cancel these x's? No, because these ones are holding hands. You can't break them apart. Can I cancel these x's? No, they're both on the bottom. You need to have one on top, one on bottom. So nothing cancels. There's no fun in that, right? So you just multiply whatever's left over. 5 times x plus 1 is 5x plus 5. On the bottom, x times x is x cubed. So it's okay to have x's on the top and the bottom. Now, your x's aren't always going to just disappear. And then my invalid values, both denominators are going to give me the same thing, okay? So I just think to myself, like, what would make zeros here? 0 would. 0 would just make 0, and then this one would be 0 squared. 0 squared would be 0. All right, so for example number 4, I'm actually going to change it so we can make the problem a little bit more fun. We haven't had very many cancels. We're going to change this bottom right fraction to become an x squared minus 1. So just change that problem a tiny bit. Now it says x plus 1 over x squared times 2x minus 3 over x squared minus 1. So I'm going to go, numerator by denominator and try to factor. So I have x plus 1. Well, there's no GCF there, can't factor anything, but I am going to put parentheses around it to remind myself they go together. On the bottom I have x squared. Really all I can do is x times x, so that's all. I don't put parentheses because they're just strangers, they're standing next to each other. On top I have 2x minus 3. I look for GCF first. Nothing divides in evenly. There's no, I put an equal sign, should be times. There's no difference of squares or cubes. There's no power of 2 or 3, but I am going to put parentheses to remind myself they are holding hands. On the bottom, I have x squared minus 1, because remember I changed the problem. This right here, right, there's no GCF, nothing divides in evenly, but there's 2 terms, and it happens to be a difference of 2 squares, dots, difference of 2 squares. These x squared, okay, it has power of 2, and then 1 is a perfect square as well. 1, 4, 9, 25, 36, those are all perfect squares. So in order to factor that, what you do is you just take the square root of each piece. You have your 2 parentheses. The square root of x squared is x, that goes in the front. The square root of 1 is just 1, that goes second, and then 1 gets a plus, 1 gets a minus. So all the factoring's done. Now we just need to see if we can cancel anything. So on the top, I have an x plus 1, and on the bottom, I have an x plus 1 as well. So we're able to cancel those out. And then I look, can I cancel these x's? No, because because they're holding hands. Can I cancel these x's? No, because this one's holding hands, so we can't do that. And we just multiply then whatever's left over. So on top you have 2x minus 3. I don't have to write the parentheses anymore. On the bottom I have x times x, which is x squared. And then I have to distribute that onto the x minus 1. So x squared times x is x cubed, minus x squared times negative 1 is x squared. I have some invalid values. There happens to be 3. So here you say, like, what would make 0, right? Well, 0 squared would make 0, so 0. Then you look at these two and you figure out what would make 0. It's the opposite sign. So if it says x plus 1, that means minus 1 doesn't work. If that one says x minus 1, then plus 1 wouldn't work. Those are your extraneous values. So we change that one so that something would cancel. All right, last example, number 5. So simplify the rational expression. I'm going to do each one. I'm going to do a different color so you guys can kind of see. So I always start, if it's a polynomial, with GCF. Is there any number that divides into all 3 pieces? No, they don't all have a variable, so there's no GCF. Then I look at how many terms there are. There's 3 terms, so that means I'm going to try a snowflake. It has to be in the form of ax squared plus bx plus c to do snowflake. So a times c on top, that's negative 5. B on the bottom, that's negative 4. X is on your little fraction part. So I need 2 numbers that multiply to negative 5 but add to negative 4. Well, the only thing that multiplies to 5 is 1 and 5. Since it's negative, one of them has to be negative though, and it happens to be the 5. So again, they're on top, they're in parentheses, they're holding hands right here. All right, then I'm going to move on to x plus 1. I look, is there a GCF? Is there anything that divides in evenly? No. Can't do squares or cubes. There's no power. So I'm just going to put parentheses around it to remind myself that they go together. All right, next up I have x plus 8. I look for a GCF first. Nothing divides into 8 and x. There's no power of 2 or 3, so it can't be squares or cubes. So I just put parentheses around it. Last one, I have x squared plus 9x plus 8. There's no GCF. Nothing divides in evenly to all of them. So there are 3 terms. I'm going to try to do a snowflake. So a times c is 8. B is 9. I need 2 numbers that multiply to 8, add to 9. So my options are 1 and 8 or 2 and 4. And luckily 1 times 8 is 8, but 1 plus 8 is 9. All right, so I get x plus 1 times x plus 8. Now that I have done my factoring, I see if anything will cancel. So I notice on top there's an x plus 1, but there's 2 x plus 1s on the bottom. So I can cancel 1 on top. That means I can only cancel 1 on bottom. It doesn't matter which one, but I can't cancel both. Okay, you can only cancel one or the other. So I'm just going to cancel the one on the same fraction. And then I have an x plus 8, and I can cancel that with the x plus 8 on the same fraction, and they go away. The x minus 5 stays, the x plus 1 stays. So for my answer, I have x minus 5 over x plus 1. So I cannot cancel the x's. Don't try to cancel these out. You can't cancel them because they're holding hands, even though I took them out of the parentheses. For my invalid values, these two are the same, right? So what would make 0? Negative 1. What would make 0 here? Negative 8. So we just say x can't be negative 1 or negative 8. So in your digital notebook, you're going to go to slide 8 and 9. On slide 8, you'll put your notes. You should only take one picture, so that's why I put an X over here. Nothing has to go on that side. On slide 9, you're going to take a picture of example 1 on page 29, and then on the right-hand side, examples 2 through 5 on page 30. Attach those into your digital notebook, and then your homework tonight is page 33 in your workbook. All right, we'll do dividing polynomials next.